what its desired width is and its desired height is based on its internal algorithms. In the second canvas, I've hard-coded the width of the letterbox to 300 pixels. As you can see at the top of the screen, the window itself is 525 pixels wide, and the canvas is also 525 pixels wide, so there's going to be some extra space in the canvas. So what we'll look at is, what does the canvas do with that extra space? Does it tell the control to make itself wider, or does it leave it alone, or does it tell it to do some other action? The third example is down here, where I have a canvas and I've specified a width of 165. So it's smaller than the size of the window. I should say on line 38, there is the width set to 300. So the width of the letterbox is wider than its containing panel. Same thing with this button. The button is also wider than its containing panel. You can see over here in the designer what's happening, but I want to run the application because I've got some tooltips available inside the letterbox that will show us the actual size and the desired size. I'll hover over the letterbox, and you can see it says desired width equal 80 and desired height equal 80, and the actual width and actual height match. So it was not affected at all by the canvas. It's the same down here, 380, 380. So even though this is wider, it didn't affect it. It's still got its desired width and height. And it's the same down here. So in this case, you see that the canvas really doesn't affect its children at all. Now I'll switch this out to another panel. Let's look at the stack panel. And run the application, press F5. You can already see things that are different. I have this one set to auto, and it's stretched to fill the entire width of the stack panel. Let's take a look at the sizes. So the desired width was 80. The actual width is 509 pixels. So this shows that the stack panel makes some decisions and overrides the desired size and sets it to a wider value. Now you can affect this with some other properties. The way you affect this is with the horizontal alignment, but I'll talk about that in the next video. Down here, we see that we have a desired width of 300 and we got an actual width of 300. And in this case, you see the stack panel decided to center this. So it honored the size and left it at 300 pixels in width. There's some leftover area inside the panel. So in this case, the default is to center that and put it in the center of the stack panel. And again, you can affect this with the horizontal alignment property. And then down here, you see the desired width was 165 and the actual width is 300. And you can see that the hello button also got truncated. So in this case, it got cut off. Now we'll change it to a grid. Run the application again. In this case, the letterbox is huge. It fills up the entire grid. And you can see the desired height was 80, and the actual height is 187. And the desired width was 80, and the actual width was 509. So that's the same as the stack panel, but the height is taller now. There happens to only be one column and one row in this grid. And so that's the entire size. Now, if I were to put columns and rows in here, then you would see the letterbox start to shrink down because it would only go in one cell. Here we are. In this case, this looks exactly the same as the stack panel, except it's higher. Again, it's got 147 for the pixels for height. And then this one, I can't even see my letterbox, and that's because of the Z index, the order that you can see, which one's in front of the other one. And because the button was put in second, my letterbox isn't even visible because it's hiding behind the button. You'll notice that the button got cut off. You can see the border is cut off on this edge. And just to show you, I'll go back over here and I'll remove the button. Control K, Control C to comment. Press F5 to run again. And you'll see that my letterbox is trimmed on this side. And my letterbox didn't make any smart decisions about this. So rather than resizing itself and showing the edges, it stubbornly clung to the fact that it was 300 pixels in width. So what I could do when I wrote my custom control is when I get the final size, I could make some changes to my element and have it shrink down to fit even though that was my original size, but I didn't do that, so I get this clipped edge here. So the point of this is that each panel has a set of rules, and they will affect the final size of the elements. So there's more than just the width. There's actually a combination of three things working here. There's the width setting, which is sometimes auto, sometimes it's hard-coded. There's the panel that it's contained in. And then there's also a property called horizontal alignment and vertical alignment that affect the sizing. And I'll talk about alignment in the next video. In this video, I'll look at how the horizontal alignment and vertical alignment properties affect the size of a child element. Here's the example I'll start with. It's on main window.xaml, and I have a stack panel. And I have a letterbox where I've hard-coded the width to 120 pixels. When the width is hard-coded, that's considered the desired width. And in this case, I'm in a stack panel, and the stack panel honors my desired width. Now, when you set the width to auto, then the element falls back to its internal rules. And in my case, for my letterbox, the internal rules are, if you don't specify height and width, to fall back to 80 pixels in height and 80 pixels in width. Now, if you look at letterbox B over here, you can see it's 80 pixels high, but it's more than 80 pixels in width. So what's going on there? Well, here's what's going on. When you specify horizontal alignment equals stretch, or vertical alignment equals stretch, you're granting permission to the panel to change the final size. So when you specify a hard-coded value, you get that value. When you specify an auto size value, you get the default from your internal algorithms, unless you specified horizontal or vertical alignment equal to stretch. In that case, you're saying, go ahead and change my width. I'm granting you permission to do that. And here's how I set that, horizontal alignment equals stretch. Now that happens to be the default, so on letterbox B, since I didn't specify a horizontal alignment or vertical alignment, it used the default to stretch. There are other settings. I'll go down here to horizontal alignment, and let's look at my other settings. I've got a left. So now when I specify left, it goes back to auto sizing it, which is 80 pixels in width, and now it moves over to the left edge of the screen. Right moves it to the right, and of course, center moves it to the center. There's also a vertical alignment, so if I go over to the stack panel and I switch this to orientation equal horizontal, now because I didn't specify a vertical alignment for any of my letterboxes, it's defaulting to stretch, and that's giving it permission to make them the height of the stack panel. And of course I can change that with vertical alignment. So that's got top, bottom, center, and stretch. Each panel makes a decision about what to do with an element when it has horizontal or vertical alignment set to stretch. So let me show you a couple of the other panels. I'll start with looking at the dock panel. Here's a dock panel where the last child fill property is set to false. I've got two letterboxes, both docked to the right side. We both have the vertical alignment set to stretch, giving it permission to make it taller than it would be normally. And I can switch this to center and this one to bottom to control their position. Finally, let's go look at the grid. This grid has 3 columns and 4 rows. And this letterbox is in column 1, row 1. And I've set vertical and horizontal alignment to stretch. So the default here is I'm granting it permission to stretch it to fill that entire cell. Center both of these, and now you see it's centered inside that cell. This also works when you set a row span or a column span property. Now I'm telling it to span 2 separate rows, so now it's currently centered between the 2 rows. I'll set this back to stretch for both. Now the letterbox is filling inside of both of those cells. From the takeaway from this is you can control how your elements are aligned within a panel by setting the horizontal or vertical alignment. If you don't set them, then you're using stretch, which grants it permission to make it larger than you might think it would be. And if you don't like that, you go in and you modify this value to one of the other values like left, right, center, or top, bottom, and center. Some of the layout panels in WPF support the overlapping of their children. 2 of the common panels that support overlapping are the grid and the canvas. When you have two elements overlap, then you have to have a way of determining which one is shown in top of the other or closer to the user. When you think about traditional 3D space, we have an x-axis and a y-axis and a z-axis. And the z-axis is usually the one that points towards the user. So in WPF, you won't be surprised to find that there's a property called the z-index. By changing the z-index value, you can move an item closer to the user or put it back to the back of the stack. In my example here, I have a canvas with two letterboxes. Letterbox D is here, it's first in the canvas, and letterbox A is second in the canvas. And if you look at the designer, you'll see that letterbox A is shown on top of letterbox D. So that implies that even though I don't explicitly set a z-index value here, it's created by the canvas when it loads the controls. And it considers this one, letterbox A, to be higher in the z-index. Now I can change that by taking this letterbox D and moving it lower on the XAML. So now it's considered to be higher in the z-index. Now it's overlapping letterbox A. So that's the implicit way of setting the z-index. There's also an explicit way of setting by using a XAML property. It's panel.z-index, and then you use a numeric value here, an integer value. So I'll use a value of 4. This one has an explicit value. This one has an implicit value. And as you can see, the letterbox A is now on top of letterbox D. I'll copy this and put it here in letterbox D. Keep your eye on the designer when I paste this in. Now, isn't that interesting? They both have a z-index of 4. So since they both tie, the canvas goes back to an implicit arrangement, and it considers D to be higher in the z-index. Of course, if I don't want that, I can change this value to 3, and that will send it to the back. There's one other thing I'd like to show you, and that's how to change the z-index in code. This is common when maybe you want to have when your mouse passes over an element on the screen, you want it to pop up on top of the rest of the elements. So you can do that programmatically. Here's the example. It's basically the same UI I just showed you. I gave letterbox A a name called letterbox A. Make this a little bit narrower so you can see what's going on in my XAML. And this letterbox here is called letterbox D. And then here's the key part. I have a mouse up event handler that fires when the mouse is pressed down and then the button's released. When you let go of the mouse button, that causes the mouse up event to fire, and this code will run. And I'll press F7 to switch to the code behind. Code itself is pretty simple. There is a method called setZindex. It's the canvas that's using this property, but it's defined at the panel level. So that's the base class for all of our layout panels. There's a method called setZindex, and there's a method called getZindex. So what I'm doing is I'm getting the z-index for this letterbox, adding a value of 1 to that, and then assigning that to the setZindex for this letterbox. So that increments the z-index 1, and when you do the mouse up on the D letterbox, it does the same thing, except now it's for letterbox D, it's setting the value and getting it from letterbox A. And this is what it looks like when you run the app. So click on letterbox A, it moves to the front. Click on letterbox D, it moves to the front. In this video, I'll look at the margin property. This is a way for an element to specify a buffer around the edges of the element. This means when you set the margin and the layout engine goes to arrange it on the screen, if there's a margin present, the element will be positioned that distance away from its nearest neighbor, also according to the layout rules of whatever panel that it's in. For this example, I'm in a stack panel that has several letterboxes. All of these letterboxes are using the default margin, which is a value of 0 for all 4 sides. Here you can see on line 14, I've specified an explicit margin value. The rest of them are using an implicit value. Now I'll switch over here and set the margin for B. This is a numeric value or a comma delimited value. I'll start by using the simplest, which is to set all 4 sides. I'll type in a number here, 10. What you see over in the designer is that the stack panel pushed the letterbox B down 10 pixels away from letterbox A. It moved the left and right edges in 10 pixels from the edge of the stack panel, and it moved letterbox C, D, and E 10 pixels further down the screen. That's because the stack panel's job is to try to lay out its children in a vertical stack and to keep each element as close as it can to the one above it. Normally, they're right up next to each other, but now because I have this extra margin, it's pushing down B and the rest of the elements in the stack panel. Let's make this bigger, 50. Now I've got 50 pixels around all four sides. And you can see that the Visual Studio Designer is also giving us some clues. The word 50 shows up here and over here. That's the left and right margin. The stack panel in Visual Studio does not show numbers for the upper and lower border, the top and bottom. I'll talk more about what these lines mean in a minute. Now I'll go to letterbox D instead of margin. There are 4 possible values to set. And in WPF, all the margins don't have to be equal. What this means is you can use a different value for each side. Another syntax for working with the margin is to use 2 values, 10, 30. So the first number represents the left and right margin, and the second number represents the top and bottom margin. The other choice is to use 4 values here. So the first item is left, then comes top, then comes right, and then the last value is for bottom. Let's go back and look at something in the designer. Let's click on this element here, and I will specify a width for this. Instead of using auto, I'll specify a width. So now it's a smaller letterbox, and you can see I now have a margin. I have this distance here of 198.5 here, but it says margin equal 50. So what I said, this number is the distance from the edge, whereas before the 50 was out here on the outside edges, that was the margin value. So the margin for the left and right doesn't make any sense anymore because it's not 50 pixels because I've shrank the size of the letterbox. So let's go back and talk about these lines. You see there's this line drawn here, and when I get to the edge, there's this chain link. There's one here on the right side and one here on the left side. This is how you can switch the horizontal alignment properties. Right now I have horizontal alignment set to stretch because that's the default. So watch what happens when I click on this chain link. That basically says unattach it from the right side of the screen, set the value to horizontal alignment equal left. So now it's left aligned, and I still have this 198 pixels. That's what I had before. So now the margin got set to 198 for the left, 50 for the top, 50 for the bottom, and 0 for the right. If I click on this again, it goes back to removing the horizontal alignment property. If I click on the one over here on the left side, it sets it to horizontal alignment equal right, and now it sets 199 pixels for the right margin, 0 for the left. Then we'll go over here and look at the canvas or grid example. Here I have a grid that has a letterbox. I'm going to remove this example. I don't need that. I specified a width and a height. Now the way you can specify the width and the height in the designer is by just grabbing these size handles here. Grab this little square on the top and raise and lower that. So this is causing 2 things to happen. It's causing the height to change, or the width to change, but it's also changing the margin values. And I can move this around with my mouse to also position it. And the way it's positioned inside a grid is by using the margin rather than using a top and left property. Here's an interesting thing about this. It's very easy to use this to drag it around. It just does the right thing. Watch what happens if I change this grid to a canvas. Canvases also allow you to select the item and move it around on the screen. So watch what happens when I drag this around. Keep your eye over here on the XAML. So the Visual Studio Editor says when you're dragging it within a canvas, we'll set the canvas.left and canvas.top. When you're dragging it around inside a grid, we'll set the margin. Now, interestingly enough here, when I moved it into a grid, the grid doesn't do anything with canvas.left and canvas.top. It ignores them. So it's using the auto size, and it's sizing it to be the full size of the one cell that's inside this grid. So I need to grab the sizing handles down here, the little rectangle. It's a bit tricky to get to because it's next to this one down here is the sizing for the window. So it might be easier to go up here and set a width and height. Now that I'm inside the grid, I'll grab this and it should erase to canvas.left and go back to setting a margin. For the last example, I'll go over to another grid and I'll add some columns and rows. Like that. Now I'll go over to my toolbox, go up here to my demo live controls, grab my letterbox, also pin this over here so I can see it, and I'll drag it inside this cell. So what I want you to see is the Visual Designer in Visual Studio does the right thing. So it put it in grid.row1. If I move it around to different places, you'll see this setting the grid.row equal 2 value. But it's also setting the margin. So as I can position it inside this cell, and that's basically setting the margin properties from the edges of the cell. This is the chapter where I look at how to create custom panels. But before I show you how to make those panels and to use them within a WPF window, let's talk about why you would do this. It comes down to when you find yourself using a certain layout pattern on the screen more than once and you want to automate that process. So here's an example. We have the need to take our elements like we have here and put them on the screen starting from left and moving them to the right. And then when we fill up the size area, we want to move down to the next row and move from right to left. And then we go from left to right and right to left. Also, while we're moving through this layout, I also want to increase the size of each of the elements so they get bigger for each item. Think of this as a stair-step layout. They get bigger. It looks like stairs climbing up stairs. Then the way I did this is I created a stack panel, an outer stack panel, and then I put 4 child stack panels in there. So each of these rows is a child stack panel. And then for this first child stack panel, I put in 3 letterboxes, and I increased the size, the height, I should say, of the letterbox for each item as it goes through the layout. And then when I got to the next row, this stack panel here, I did 2 things. I set the flow direction to right to left. That means that even though this is the first item in here, it goes D, E, and F in my stack panel. The way they're shown on the screen is right side to left side. And I also had to set this property horizontal alignment equal left, because if this value wasn't here, if it was set to the default value, which is stretch, then the second stack panel would have started here on the edge of the window, and that's not what I want. So I set this to left, so it aligns with the other parent stack panel. And then I just have 2 more stack panels below that to do the same thing. So here's the deal. This works, and it shows you how you can do more complex layout in WPF. But let's say that we have a scenario where we need to reuse this stair-step layout in more than one section in our application or across applications. So rather than building this set of stack panels, what I can do instead is create a custom panel. And then I put some rules inside the custom panel that tell it what to do with its children elements during the layout passes of the application. So I specify where the items go, and I specify what size they are. And once I get that logic created and put in the custom panel, I can then reuse it. All I need to do to reuse it is add my custom panel to the window, drop some controls into it, and it takes care of all the work of moving the items around in my custom pattern. Before I show you how to create your custom panel, I thought I would show you some examples of some custom panels so you get an idea of what you can do with panels. In this application, the implementation looks like this. I have a panels folder in my project,